Alright, welcome back to our worksheet 5C. This is will be a summary for our whole topic itself. So I hope that you have already completed worksheet 5C. Okay, so let's take a look at the answer first. I'll give you the answers. 1 is D, 2 is C, 3 is D, 4 is B. Okay, so let's take a look at question 1. Question 1 wants you to find where is the likely place for the center of gravity of the setup. So we have it hung freely from point X. So in this case, if I take the corner, I draw a dotted line. If I take the edge, so it is something like a triangle. Okay, so the center of gravity should be around C. So C should be the center of gravity, but the answer is not C. Why? Because now they hang an iron block at the bottom. So when you makes it heavier at the bottom, what will happen to your center of gravity? Correct. It lowers center of gravity. So in this case, center of gravity will be at D. Okay. So look at 2. Diagram right shows two egg-shaped objects, X and Y. There is lead embedded inside. Which of the following correctly describes the type of equilibrium? So look at X. Center of gravity should be slightly higher up. Center of gravity is here. So which of the following describe the types of equilibrium for object X and Y? So if I were to give this a push, I push it this way, what will happen to it? It most likely will be here. Center of gravity should be lower. So this is the original height. Now center of gravity is here. So what will happen? Center of gravity becomes lower. When the center of gravity becomes lower, it is unstable. Next one. If I give this a push, let's say if I push it this way, what will happen? It will be tilt. Sorry. It will be tilt like that. Center of gravity may rise up a bit. It's not very accurate. It may rise up a bit. Thereafter, it will come back down again. Then it is stable. Okay. Some of you may ask why is it not neutral? Because there is still one part where you can rock it up and down. If it's new, some of you are asking why is it not neutral? So if you can rock it up and down like that, it is not neutral anymore because your center of gravity can be adjusted. Okay. If it's same throughout, then it's neutral. Center of gravity is same throughout. Okay, question 3. So there is a toy bird here. The manufacturer needs to determine the position of the center of gravity. In which position A, B, C, D should the center of gravity be? We want to look at which point will the center of gravity increase and then come back to its original position. So we are looking at center of gravity to increase and return back. So now imagine let's push this bird down. What will happen to the center of gravity of A? Yep, it becomes lower, so A is out. How about B? If you push it down, yeah, SKIV first. C, if you push it down, what will happen is it may go back up. Okay, maybe. Okay, what happens now if I change my direction of force? What happens if I push it this way? Okay, then B, center of gravity will go down. Your center of gravity will have to shift down because when I push this way, the bird will turn this way. Your center of gravity should go down also. So B is also out. Center of gravity of C will also go down. So it's out because remember why we want the center of gravity to increase. So for D, what happens here if you push the bird down here? Center of gravity goes up. If you push, let's change the direction of how we push this toy bird. Now if we push it this way, center of gravity will go up. So and it will come back to the original position. It's exactly like a pendulum. Okay, that swings. So answer is D. We want the center of gravity to increase and then comes back to the original position. But for the other three, A, B, and C, it can actually go up or it can go down. Sorry, most of them will all go down, the center of gravity. Okay, let's look at 4. Some of you may say that this question you don't understand what it's talking about, so let's take a look. A non-uniform tree trunk has a weight of 1000 newtons, so they tell you that the weight is 1000. Rest horizontal on two support Q and S. Center of gravity is at R, so here's center of gravity. What is the minimum downward force that must be applied? So you want to apply force here to lift it off. So you want it to just nice balance it. So you use the principle of moments. Okay, so let's take the moments about Q. Why? Because you want to lift off S. So this will be a pivot. Okay, so there's R here. Your distance from here to here is 3 meters. The distance from here to here is 4 meters. So you have a very simple problem to solve actually. So 1000 times 3, so this is your clockwise. Uh, P times 4, this is your anti-clockwise. Okay, then you equate, you can find for FP, which is 750, is B. Yes, so why don't you consider S? Because you're going to lift it off S will not be a pivot anymore. Okay. All right, 1A. Define the term center of gravity. Center of gravity is a point through which the whole weight appears to act on. How about the center of gravity for each of the object is in the center. So just find the geometrical center of it, and then that should be fine. Same for the sphere, geometrical center, where is the center of the whole object. Same for the cylinder. Okay, C. Explain why the inverted conical flask in 5.17 is easier to topple when disturbed than the identical inverted flasks. So what is happening here is the flask here has items inside that cause its center of gravity to increase because now the mass is all pulled upstairs here, but this one has nothing inside. So the center of gravity will increase. On the same time, the base area is smaller. Okay, so let's take a look. By filling a conical flask with sand and inverting it, the center of gravity of the conical flask is shifted upwards. So your center of gravity increased. So originally, center of gravity should be around here. But once you bring in more things, center of gravity shifts up higher. Okay, so center of gravity is higher. A higher center of gravity coupled with a small base area, so that small base area makes the flask more unstable and easy to topple over. So what is the moment of a force? Moment of force is the turning effect of a force about a pivot. How can it be determined? You just take the product of the force and the perpendicular distance. Name the SI unit. SI unit Newton meter. Okay, let's look at B. B itself, we have discussed this before. Take A, we have a door, hinge at A, so this is the pivot here, pivot P. A woman applies a force F at 40 newtons. Okay, and then there's another force at X. Calculate the moment exerted by the woman. So moment equals force times distance. Remember, write down your formula first. The woman is exerting a force of 40. Distance is 1.8, so 40 times 1.8. Remember, must be perpendicular distance. So this is 72. What direction is this? Yes, anti-clockwise. Here, clockwise. What is the minimum force needed to be applied at C? So they want to ask what is X in order for the door to stop turning. So you want to have the same moments both sides. So you want the clockwise moments to be equals to the top, which is 72 newtons meter. So you want X times this to be equals to 72. So let's take the math. So the moments, clockwise moments is equals to X times 1.2. And you want this to be equals to 72 newtons meters so that you can just nice balance and stop the door from moving. So how do you do the math? Just do the triangle. X times 1.2. Upstairs is 72. So when you want to find X, cancel X. So X equals to 72 divided by, this line means divide by 1.2, so you get 60. Okay. Say the principal moments. I will not go through this. You can just check your previous notes. Okay, I want to look at B. B is slightly tricky because you got to be very careful with how they calculate the measurements. So this is a meter ruler, 1 meters long. There's a marking of 0, 50, 60, 100, and 30 cm mark. This does not mean that this is the number for the perpendicular distance. Why? From here to here, this is 30 cm. From here to here, this is 50 minus 30, which is 20 cm. Okay. From here to your 2 Newton, this is 60 minus 30, which is 30 cm. And your last one is 100 minus 30, which is 70 cm. 100 minus 30. So you got to be very careful. We want to look at 30 cm, 70 cm, and 20 cm. So what is the weight W? They want you to find this. Okay, so similarly, take the moments about the pivot, write down the formula. See, this too is very important. Make sure you have this so that you will be able to handle now, because it's not only one force or two forces. One, two, three, four. Four forces. That's why we need to have the sum. Okay, so let's do the math. One. Let me see if I can change my color. Okay, let's change to blue. Okay, so we have 1 times 20. So here, 1 times 20. This is for the clockwise moments. The other one is the anti-clockwise moments. Next, we have 2. 2 times what? 2 times 30. Next, we have W. W times what? W times 70. So what is the anti-clockwise? 12. 12 times what? 12 times 30. You do the math, you'll find that W equals to 4 newtons. Okay, so you just got to be very careful and slow. All right, let's look at the last one. 300-gram walking stick is placed on a pivot and balanced by a 100-gram mass. Calculate the distance of the center of gravity from the stick. So if this is balanced, means center of gravity is somewhere here. Okay, and in this case itself, here is balanced by a 300-gram walking stick. So W equals to mg. Be careful because this is mass. This is mass. So the weight of the walking stick is equals to 0.3 times 10. Why 10? That is the gravitational field strength. So this is 3 newtons. Whereas for the weights of a mass is equals to 0.1 times 10. Why 0.1? Because I'm using kg. So this is 1 newton. Okay. So let's change this. This will become 1 newton. Your weight will be equals to 3 newton. Okay. This is 15 cm. This distance from here to here, the perpendicular distance, we do not know. So let's put it as D. Okay. So taking the moments about the pivot, remember to add in your sum of clockwise equal to sum of anti-clockwise. Let's calculate. So we have, this is 3 newtons times what? Times D. So we have here. Here is 1 newton. This is 1 newton times 15. So we have it for this side. Do the math, because they should equal. You'll get the distance is 5 cm. Okay. So the center of gravity from the pivot is 5 cm away. So here to here, this is 5 cm. All right. Guess that's all for this chapter. You did well. Have a good day ahead.